and welcome to Tribe Topper. In this video session, you're going to learn about phase and phase difference. So let's try to understand what do we mean by phase. See, phase refers to the position of a point in time on one cycle of a waveform. So if I draw a waveform, we either say we refer to the position on that waveform. So one complete cycle is 360 degrees. That is also known as a phase. So that's one full phase. Now to understand, actually we don't use simply the term phase, but we rather use the terms in phase, out of phase, or a phase difference. So as you can see here in this figure, what is it showing? That each bob, I have taken two bobs here, each bob is displaced to the right and then released at the same time. So you took both the bobs, pulled them to the right. As you can see, this is the vertical line. So both have been pulled to the right extreme and released. They will set up into oscillations which will be absolutely in phase. So the oscillations, because they will cross the mean position at the same time, go to the other extreme at the same time, then come back. So they are in harmony with each other. So all the time they will oscillate together. So these oscillations are in phase. But if you look at this figure where we have pulled one bob to the left extreme and the other bob to the right extreme, so then you release. So this is pulled to the right and released, this is pulled to the left and released. So when this will go to the left, this bob will go to the right. When this bob will come back to the left, this will go to the right. So at each moment of time they are heading opposite to each other. So we would say here that these oscillations are out of phase. So when the two things just move absolutely opposite to each other, they are completely out of phase. And out of phase means that there is a phase difference of 180 degrees. That's completely out of phase. Here we had completely in phase, so there was no phase difference, or we would say that that is a phase difference of 0 degrees. So the in phase means when you have two best friends all agreeing with everything, moving out together, whereas this is where you just argue for everything opposite. So one goes to the left, the other goes to the right. So that's what corresponds to phase difference of 180 degrees. Let's have a look at the three graphs where, like when we talk of a simple harmonic motion, the displacement, velocity and acceleration, they are all sinusoidal waves, as you can see, but they all start from the different points. All these waves, the difference between them is that they all start at different points. Like if you see, I've placed them all together one below the other. So the first one is the displacement versus time graph. The second one is the velocity time graph. And the third one is the acceleration time graph. So if you look at it, the first graph, that is starting at 0 seconds, it starts from 0. Whereas the velocity, in this case, at 0 seconds, start from a maximum. So this is not exactly opposite, but this one is ahead. So here we would say the phase difference between the two is just 90 degrees or pi by 2. Of course there is a phase difference of pi by 2 because this is a sine wave and this has turned into a cos wave, because sine wave, the first one is sine theta. In that, if you add a phase of pi by 2, you are going to get cos of theta, and that's what you get as the velocity wave. Now in this velocity wave, you again add another pi by 2, so you are going to get minus sine theta. So from trigonometry, you already have that knowledge that cos of theta plus pi by 2 is minus sine theta. Now from here, if you add theta pi by 2, you get what? The acceleration. So when this is at maximum, this is 0, this comes down, this goes to the negative direction. So you have a negative sine wave. So you see there is a phase difference of pi by 2 between the displacement and velocity and between the velocity and acceleration. So what is the phase difference between the displacement and acceleration? Also, from the graph you can make out, we have always been talking of a is proportional to negative x. This also tells us that they are directed absolutely opposite to each other. From the graph also we can make out that when x is positive maximum, your acceleration is negative maximum. Straight away indicates that these two are opposite waves, completely out of phase. So here the phase difference between the displacement and acceleration is pi, or 180 degrees, because they are completely out of phase. So this is the phase relationship between the displacement, velocity and acceleration of simple harmonic motion. So let's do a problem here based on displacement time graphs. We want to find out what is the phase difference between these two displacement time graphs. So we are given two displacement time graphs, as you can see, one below the other. What is the phase difference between these two if we tell it in terms of seconds? So to find the phase difference, we will draw two lines from the peak of each. So one has to pass from the peak of the top wave, one has to pass from the peak of the bottom wave, and we'll see how much gap is there in between them on the time axis. So let's see here, how much is the difference between these two lines. So one line I've drawn starting from the top peak, and the other line I've drawn starting from the peak of the bottom. So because their peaks are not happening at the same time, so there is some phase difference for sure. So how much is the phase difference? This much distance on the time axis. So each division is corresponding to 0.2 seconds. So one division is 0.2 seconds. If you'll see carefully, it is ahead of 0.2. So this is 2.0, 2.2, 2.4. So this is almost 0.25. So there is a phase difference of 0.25 seconds. But now they want the answer for B part, the phase difference in radians. So in radians, how would we find that? See, one full time period. When we talk of one time period, that will be in which one full wave is completed. So the phase angle of one full wave is 2 pi radians. So one time period, how much is the time period of each wave? It is 2 seconds. You can see the first wave starts from here and ends here. That is 2 seconds. The other wave starts from here and ends here. So that is also 2 seconds. So this 2 seconds, if we convert it into radians, how much would that be? 0.2 seconds is 2 pi radians. Therefore, a phase difference of 0.25 seconds would be how much radians? 2 pi over, sorry, that is not 0.2, it's 2 seconds. My mistake. So it's 2 seconds. So 2 seconds correspond to 2 pi radians. So 0.25 seconds would correspond to 2 pi by 2 into 0.25, and that would give us 0.79 radians. Now in the last part they ask what will be the value in degrees. So in degrees we will have a value of we'll just say 0.2 seconds. We'll convert it with degrees as 360 degrees. So if 2 seconds correspond to 360 degrees, then 0.25 seconds correspond to 360 upon 2 into 0.25, and solving this you get 45 degrees. So this is how you can calculate the phase difference. So always, if you have to evaluate it from the graph between two waves, just draw the lines from their peaks and see how much is the difference between them. That's all. So that's all for this video session. In the next video lesson, you are going to learn about the energy changes in simple harmonic motion. Thank you for watching.